Alright, so this is the third part of the videos explaining the calculations for Part C of Experiment 1. The other thing that I've noticed people struggling with are calculating deviations, and the average deviation. So first of all, deviation means how much something deviates, right, is different from. And so here we're looking at how far each measurement is from the average of those measurements. Remember here, I'm just showing you these examples for the made-up numbers for, let's say, the graduated cylinder. You're going to do all these for the volumetric pipette, and then again for the burette. So here, okay, to calculate the deviation, you're going to take the absolute value. This is really important. Notice the absolute value bars here. You never want a negative number for a deviation. Always should be positive. So these numbers, if you remember from part 1 of these videos, are the numbers I made up for the average, for each of the individual measurements, the mass of 10 milliliters of water used in a graduated cylinder. This, and this. This is what we calculated in the first part of the first video as the average. Notice the 4 places past the decimal. So again, sig figs. What we're doing is subtraction, so what we care about is where the last sig fig is. In this number, it's 3 to the right of the decimal. The last sig fig in this number is 4 to the right of the decimal. And so this number is less precise than this because the last sig fig is farther to the left than it is here in the number, towards the decimal. And so that means we get to keep 3 places to the right of the decimal. Well, these particular numbers, that ends up being 0.016. That's 3 to the right of the decimal. And notice I'm not rounding yet, so my first insignificant figure is also a 6. Your numbers are going to be different. You might have 3 sig figs, 0.123 or something like that. You might have 1 sig fig, 0.004, whatever. But it's going to be, for everybody, it'll be 3 places past the decimal. C2, I get this, and C3. So now I have 3 deviations. Next, to calculate the average deviation, all I do is add those 3 numbers up and divide by 3. Once more, looking at significant figures, we have to show each step, each in the order of operations. The first step is to add the numbers together, and because we're adding, we care about where the last sig fig is. In this number, it's 3 to the right of the decimal, 3 to the right of the decimal, 3 to the right of the decimal. So we get to keep 3 places to the right of the decimal, which ends up being, again, for these numbers I made up, 0.058 sub 6. Again, your numbers might give you something like 0.123 or something like that, 3 sig figs, or maybe 0.007, whatever. But it's going to be 3 places to the right of the decimal. Now the last step here is to divide. Remember, just like before, we're taking an average. This 3, because we're counting how many times we did something, this is an exact number. This number has 2 sig figs, 1, 2. Remember, the zeros are leading, they don't count. And so 2 sig figs divided by an exact number, we get to keep 2 sig figs, which for me was the numbers I made up, 0.019. Then the first insignificant figure, the first number we're dropping is a 5. So we round up, which gives us 0.020 grams. Again, for the numbers I made up. And that's how you do it.